Welcome to this session. Today we are going to learn about principal component analysis or PCA, a powerful technique used in machine learning and data science. So what exactly is PCA? PCA is a technique in machine learning used to reduce the number of features or dimensions in data while still keeping the important information. In simple words, it makes our data set smaller and simpler but without losing the key patterns that really matter. Now let's define it properly. PCA is a dimensionality reduction technique used in both machine learning and statistics. What it does, so it takes features that are correlated with each other and transforms them into a smaller set of new features that are uncorrelated. These new features are called principal component analysis. The correlated features and uncorrelated features, we will be seeing this in the forthcoming slides. So what is the purpose of doing this? The main goal of PCA is to reduce the number of features while still retaining the maximum possible variance in the dataset. Variance here simply means information or spread in the data. So we are throwing away the less useful parts away from the center and keeping only the most meaningful parts. And so PCA finds the most important directions in the data and helps us reduce complexity while still keeping the essence intact. So what are the benefits of PCA? It reduces computational cost by lowering the dimension. It removes redundant correlated information and makes a data visualization easier in 2D or 3D parts. So the applications are image compression, face recognition, finance, genomics, any data set with high dimensional features. So now let us understand this PCA with a very simple analogy. Imagine you have a huge textbook with 500 pages. Your exam is tomorrow and obviously we don't have time to read all the 500 pages. So what do? You create short notes. Maybe you bring it down to just 50 pages that capture only the main points. Even though you reduced the number of pages, the important ideas are still there. You haven't lost the essence of the textbook. You have just removed the extra details. So, and that is exactly what PCA does with data. It reduces the number of features, like reducing the pages, but still keeping the core information and patterns intact. So the PCA is basically like making a smart notes from a big textbook shorter, simpler, but still meaningful. So let's look at another example to understand the PCA, the shadow trick. Suppose you are looking at a 3D object like a football. Now, if you shine a light on it, the ball casts a 2D shadow on the ground. Yes, the shadow is in fewer dimension. It is flat and it's just 2D instead of 3D. But even from the shadow, you can still recognize the ball as a football. The essential structure is there even though we lost one dimension. See, the 3D object is now here. This is a 2D shadow of the 3D object, and that's exactly what PCA does with the data. It takes data with many dimensions or features and create a smaller set of dimensions called principal components. Even though the number of dimensions is reduced, PCA still manages to capture the main structure and the important patterns in the data. So now we will see about what is correlation and no correlation, right? So this is an example for strong correlation, which is duplicate information. Suppose whenever a student marks See, we can take this as an example with the student marks, right? So we have 5 students with maths and physics marks. Suppose whenever a student's maths score grows up, their physics score also grows up almost in the same way. If we look at the numbers closely, the physics is almost a copy of the maths. So keeping both subjects doesn't really add much information. Physics is just repeating maths story. So this is where PCA becomes useful. Instead of storing both the maths and physics separately, PCA can combine them into one subject called the PC1 without losing much meaning. So by doing this, we don't lose the meaning of the data, but still get rid of the duplicate information. PCA keeps the essence while simplifying the data set. So this is where maths and physics are strongly correlated to each other. Now let's look at a different situation. Notice this, a student who is good. So we will consider a table here, the same 5 students. Here, what we have noticed is the student who is good in maths might actually be weak in physics. So here the score does not move together. Maths mark and physics mark are telling different stories. In this case, physics is giving us a new information that maths alone cannot do or cannot explain. So that means we cannot throw away either subject. We need both maths and physics to fully understand the student performance. So when features are not correlated, PCA recognizes that both are important and it keeps them. So now you have both cases, strong correlation, PCA will combine into one component, and no correlation, PCA keeps both because they add unique values. So what duplicate information mean? So what do we really mean when we say duplicate information? If two features are strongly correlated, like in example 1, they are basically saying the same thing. That means we don't need both. PCA can safely reduce them into one dimension without losing much meaning. But if two features are uncorrelated, like in example 2, they are telling different stories. In this case, we cannot drop either one because both carry unique information. So PCA's role is to figure out which features are to be or duplicates and can be combined, and which features are independent and should be kept. So at the end of the day, PCS job is very clear. So it looks at your data set and ask 2 questions. First, which features are basically duplicates, just repeating the same story. If it finds them, PCA merges them into a single principal component. Second, which features give unique information. Those PCA, those PCA will keep separately because they add real value to understanding the data. This way, PCA simplifies the data set but removing redundancy, but still keeps all the information, important information intact. Thank you.